goods.
Not really, no. I'll tell you a bit more. All right, so let's get straight into derivatives of exponential functions. So here's our rule here, and this is hence the meme on the front of the page. We have y equals e to the x, and then if you differentiate e to the x, you get e to the x. This is the only function for which this is the case. When you differentiate the function, it remains the same. E to the f of x, however, is a little bit different. If we have e to the f of x, when we differentiate it, we have the derivative of the function out front followed by e to the f of x. So let's get straight into it. Here we have y equals 3 times e to the 2x plus 5. We're going to differentiate this in one step. Now, whenever we have a number out the front that's multiplying, we're just going to leave that there. It's 3 times whatever the derivative function is. So, for our derivative function here, we have e to the power of 2x plus 5. We have e to the power of a function. All right? So, e to the power of 2x plus 5, what we'll do, differentiate 2x plus 5, that will be 2. And then just e to the 2x plus 5. Okay? So, let's explain that one. The 3's hanging out. We do the derivative of the power. The derivative of 2x plus 5 is 2. And then we just have e to the power. Alright, so this part stays the same. And then that's just the derivative of it. Everyone see that? Cool. Alright, onto this one here. We have x squared multiplied by e to the x. So here we have to use the product rule. So u is x squared, u dash will be 2x, v is e to the x, and v dash we know from here, if we differentiate e to the x, we get e to the x. If we differentiate e to the x, e to the x. Okay, so then for the product rule, we'll just smash all of that together. dy dx is u dash v plus, product rule plus, uv dash. Okay. I'm just thinking maybe let me just have a look at the technical questions, and we'll either go through example C. It is quite a. It's probably not the best indication of e to the 4x. I think let's just do one. I'll just point out one more, for example. If we have y equals e to the x squared plus 3x, okay, if we're differentiating something like this, okay, we can see clearly we have e to the power of a function of x, right? So the derivative then, all we do is differentiate the function, that's going to be 2x plus 3, and then e to the f of x. Okay, so that's how we're doing derivatives of exponentials. Another thing that will pop up in this exercise is when we have x on top of 2. Anytime, and I've said this before, even if we have like sine x on top of 2, or e to the x on top of 2, even if it's not on top of 2, it could be on top of 7. We should always think about this. This is what I said when I said dividing is the same as timesing. All right? That x divided by 2, that's the same as half times x. We should always think about it like that. It is kx, because the derivative of kx is k. All right? If it's sine x on 2, no, it's not. It's half times sine of x. Okay? E to the x on 7, no, it's not. It's 1 on 7 times e to the x. It's always a number out the front. We just treat it as a number, and that makes the differentiation much easier. So this will pop up specifically in this exercise. All right, so probably what I'd like us to do then is maybe make